This paper is chemistry paper 1 for Form 6 student or NECTA Form 6 chemistry paper 1 2019. Ni chemistry paper 1 2019 kwa kidato cha 6. This paper, it has section A, B, C. Total 14 questions. A student supposed to answer 4 questions from section A, 3 questions section B, and 3 questions from section C. So students supposed to answer 10 questions. Each question carries 10 marks. Kwa tuanze na section A. Mtoto anatakiwa jibu maswali 4, section B maswali 3 na section C maswali 3, jumla maswali 10. Kila swali lina max 10. Kwa hiyo mtoto anatakiwa jibu maswali 10. Section A, swali la kwanza ni general chemistry na swali la pili ni general chemistry. Kwa chemistry paper 1, question number 1R. Use SPD notation to designate atomic orbital of the given pair of quantum number. N and L. Use orbital S, P, D, and F. Use S, P, D, F to sign orbital of the given pair of quantum number, N and L. Roman number 1, N is equal to 2, and L is equal to 1. These two quantum numbers describe what kind of orbital. N represents number of shell, L represents subshell. N represents number of shell and L represents subshell. So N is equal to 2 represents shell number 2, and N represents shell. There is shell number 1, 2, 3, 4, and etc. Subshell start with 0, 1, 2, 3. 0 represented by orbital S, 1 orbital P, orbital D, and orbital F. So N is equal to 2. Describe quantum number 2. L is equal to 1. Describe orbital P. So describe 2 P orbitals. N is equal to 2, represent number shell, 2 number shell. Now L is equal to 1, represent P orbital. So N is equal to 2, L is equal to 1, describe 2 P orbital. N is equal to 3, and L is equal to 2. Describe shell number 3, and the subshell, which represented by L is equal to 2, known as D. So describe 3D orbital. Number 3, N is equal to 4, and L is equal to 3. Kwa n is equal to 4, hiyo ni sheli ya 4, na l is equal to 3 ina represent which is subshell. N is equal to 3 represent subshell F. Describe for F orbital. Number 4, N is equal to 3 and L is equal to 0. N is equal to 3 represent shell number 3. So describe shell number 3. L is equal to 0. L is equal to 0 represent S orbital. So describe 3 S orbitals. Describe shell number 3, orbital S. Shell number 3, orbital S. Question number 1, B. Question number 1, B. For the following set of quantum number, state which are allowable and which are not allowable. Briefly explain your answer. You are given number of quantum number to explain if it is correct or not correct, or allowable or not allowable. Roman number 1 being n is equal to 2, L is equal to 2, M0 is equal to 0, and M is equal to positive, that one. So you are supposed to account if it is correct or not correct, if it is allowed or not allowed, and briefly explain if it is correct or not correct. N is equal to 2 represent shell number 2. N is equal to 2, shell number 2. Each shell is subdivided. The number of subshell, kila shell imegawanyika. Shell ya pili imegawanyika mara mbili. Kugawanyika mara mbili tunapata 2s na 2p. S ni 0 na p represented by 1. Each subshell is subdivided. S haijagawanyika, inakuwa represented by 0. 0 represent S. P, it has 3 orbital, 1, 2, 3. And this 3 orbital represented by negative 1, 0, positive 1. Or range from negative 1 to positive 1. Range from negative 1 to positive 1. To positive 1. Total number of orbital of P range from negative 1 to positive 1. So here there is a 0. So MSC, this it has 2 electrons, positive, negative. Positive, negative. Each orbital have 2 electrons. One among 2 and another one among 2. Positive 1, negative 1. Each orbital it has 2 electrons. Kwa hizi ni electrons mbili za orbital S. So for n is equal to 2, for n is equal to 2, you are given L is equal to 2. Kwa hiyo tuangalia L is equal to 2 hapa inapatikana. L is equal to 2 haipatikani. Kuna L is equal to 0 na L is equal to 1. Kwa hiyo L is equal to 2 haipo. Kwa hiyo hii set of quantum number tuliopewa sio sahihi. Kwa sababu n ikiwa 2, yani shell namba 2, imegawanyika mara 2. Kuna 2s na 2p. S inakuwa represented na 0, p inakuwa represented na 1. L is equal to 2 ina represent 0, 1s, 1p, d, f. Kwa L is equal to 2 haipo. Kwa hiyo these not allowable. Are not allowable. Set of quantum number set of quantum numbers are not allowable. Not allowable. Because n is equal to 2 have no, n ikiwa 2 haina error is equal to 2. Ina maximum error is equal to 1. Maximum error is equal to 1. Have no error is equal to 2. Is not allowable. Is not correct. Because n is equal to 2, have no error is equal to 2. Number 2, n is equal to 3, error is equal to 1, m error is equal to 0, and MWS negative that one. So account if the given quantum number are correct. Ili uweze kulijua ili ni correct au sio correct, inabidi uchanganue sabusheli zote za sheli ya 3 na sabusheli zote za sheli ya 3 na orbito zote za kila sabusheli. Kwa hiyo find the value. Find the value. Kwa hiyo tuchanganue n is equal to 3, sabusheli zake ni zipi? Orbito zake ni zipi? Tutajua kama hii ni correct au sio correct. So n is equal to 3 ni sheli ya 3 imegawanyika mara 3. Ina 3s, 3p na 3d. S inakuwa represented na 0 kwa 0. P inakuwa represented na, this represented by 0, 1, 2. Mwelo ya S 0 ana box moja. P ana orbito 3 zinaanzia -1, 0, +1. Na D anakuwa represented na 2, D ana orbito 5 zinaanzia -2, -1 is 0, +1, +2. Kwa n is equal to 3, sabusheli zake ni 0, 1, 2. Total orbito, S ina orbito moja, P inaanzia -1 to +1, D inaanzia -2 to -2. So given n is equal to 3, n is equal to 3, ipo. Error is equal to 1, error is equal to 1, ipo. Error is equal to 0, error is equal to 0, zipo nyingi tu, ipo, ipo, ipo. Na MWS ni -1. Kila orbito ina -1 na +1. Kwa hiyo hii ina -1, +1. Hii ina -1, +1. Kwa hiyo it is allowable. Set of quantum number are allowable. The set of quantum number are allowable because n is equal to 3, have error is equal to 1, m is equal to 0, and MWS is equal to that one. Swali number 3, Roma number 3. Roma number 3, tumepewa seti za quantum number, tuchanganue kama ni correct au sio correct. Roma number 3, n is equal to 1, error is equal to 0, m is equal to +1, MWS is equal to +2, that one. Kwa hiyo n is equal to 1, hiyo ni sheli ya kwanza. N is equal to 1 represent first sheli, and you are supposed to know subsheli and the orbital and the electron of first shell. Kwa hiyo tukichanganua shell ya kwanza imegawanyika mara ngapi? N is equal to 1 ina subshell moja tu, inaitwa s 0. Box au orbital nayo moja tu. Electron ana -1 na +1. Kwa hiyo electron ana -1 na +1. Kwa hiyo N is equal to 1 ipo. L is equal to 0, 0 ipo. S. Mwero +1 amna. Kwa hiyo are not correct. Set of quantum number are not allowable. Because N is equal to 1, have L is equal to 0, but have no M1 is equal to +1. No M1 equal to hakuna +1 ya kwenye sheli ya kwanza. Kwa sheli ya kwanza ina subsheli moja inaitwa 1s, value yake ni 0. Ina box moja au orbital moja ina value ya 0 na ina electron mbili. La mwisho number 4, N is equal to 3, L is equal to 2, M1 is equal to +2, MS is equal to that one. Kwa hiyo nenda kuchanganua sheli ya 3. Je, samani za quantum number ulizopewa zipo? N is equal to 3. Sheli ya 3 ina subsheli 3. Nazo ni 3s, 3p na 3d. Value of s 0, value of p moja, value of d 2. Mwero inaanzia -1, 0, +1. Inaanzia -2, -1, 0. Okay, N is equal to 3, pleasant. L is equal to 2, pleasant. Mwero +2, pleasant. MS negative, each orbit have negative. Kwa hiyo zote zipo. Kwa hiyo tunasema is allowable. Sets of quantum number are allowable. Allowable. Question number 1 is C. Define the following phases: atomic number, mass number. Atomic number is a number of elements written below. Mass number above. For example, potassium has the atomic number 19 and atomic mass 39. Kwa hiyo hii ni namba ya atom kwenye periodic table. Hii ni uzito wa atom. Kwa atomic number walizipata kwa kuhesabu idadi ya proton, positive particles in the nucleus. Kwa atomic number is the number of proton in the nucleus of an atom. Atomic number is a number of proton in the nucleus of an atom. Is a number of proton in the nucleus of an atom. Atomic mass, written as superscript, ni uzito wa atom. Atom ina particle 3. Hapa kuna electron, humu kuna proton na neutron. Proton na neutron zina atomic mass au zina uzito, atomic mass unit. Electron haina uzito. Kwa uzito wa proton moja ni gramu 1 na uzito wa neutron 1 gramu. Kwa akiwa na proton 10 atakuwa na gramu 10. Akiwa na neutron 11 atakuwa na gramu 11. This plus this one is equal to 20. Kwa hiyo is the sum of proton and the neutron. Mass number is a sum of proton and the neutron in the nucleus of an atom. In the nucleus of an atom. Question number D. Question number 1D. A nucleus of certain element is presented as element 27, 58. A nucleus of certain element presented by X 27, 58. What is the number of electron and the neutron in an atom X? Show your work clearly. Atomic number is a number of proton in the nucleus of atom. And the total number of neutron in an atom is equal to the total number of electron of that atom. Kwa kuwa atomic number ni namba ya proton kwenye nucleus na idadi ya proton katika atom ni sawa na idadi ya electron, and a number of proton is equal to the number of electron of that atoms. Hence, element X has number of electron (27). Atomic mass is equal to proton plus neutron. Number of neutron is equal to atomic mass minus proton. Atomic mass of this element given 58. Number of proton 27. Number of neutron 1, 3. The number of neutron of element X is 31. 31. Kwa hiyo na idadi ya neutron 31. Kwa sababu unachukua mass number to atomic number, you get that one. The last question, number E. Clearly state four postulates of Planck's quantum theory as derived from black body radiation. Postulate of Planck's quantum theory. Postulate point of Planck's quantum theory. Pointing of this theory. You are supposed to state the point of Planck's quantum theory. Planck's. Point number 1, as suggested by Johannes Planck. As suggested by Johannes Planck, any radiation is associated with the energy. Any radiation is associated with the energy. So radiation, it has energy. Point number 2 of Planck's quantum theory. The radiant energy or radiation associated with the quantum, the energy of radiation is direct proportion to frequency. Point number 3. An energy released, not continuous, but in a small packet known as quanta. Radiant energy is absorbed or emitted in a small packet known as quanta. Small packet. The radiant energy emitted or absorbed in a whole number of quanta. Any radiation associated with energy. Point number 1. Associated with energy. Associated with energy. Radiant energy associated with quantum is direct proportion to frequency. So the energy of radiation is direct proportion to frequency. Point number 2. Number 3. Radiant energy emitted, not continuous, but in a small packet Number 4, radiant energy absorbed or emitted in the Warren number, of quantum. Kwa pointi za Planck ziko 4. Ya kwanza anasema radiation imebeba energy au radiation contain energy. Any radiation contain energy. Point number 2, energy of radiation is direct proportional to frequency. Kwa radiation iko na frequency kubwa na energy kubwa. Radiation iko na frequency ndogo na energy hiyo radiation itakuwa ni ndogo. Point number 3, anasema radiant energy is emitted, not continuous. Vitu vinavyozalisha radiation, ile radiation inazalishwa sio continuous. Inazalishwa kwenye vipacket, smallest packet. Hizi packet za radiation akaziita quanta. Kwa the radiant energy inazalishwa, wanasema sio continuous. Inakuwa kwenye packet ndogo ndogo, tunazita smallest particle. Hizo packet tunaziita quanta. Na vile vile radiant energy inakuwa absorbed or emitted in a whole number of quantum. Ina maana hizi particle ni namba nzima, zinaweza zikawa packet 5, 6, 8, lakini haziwezi zikawa fraction, maybe 0.5, 0.8, 0. Haiwezi kawa fraction au decimal. Hizi packet zinakuwa ni whole number of quantum, na zinakuwa not fraction or decimals. So these are 4 point of Planck's quantum theory. 4 point of Planck's quantum theories. This question is from general chemistry. First topic in form 5.